All right, real briefly, what I wanted to do was to summarize the main points in Lesson 1. So this is going to be pretty much the fourth screencast for Lesson 1. And what I did is I just turned my lesson over, okay, to the back where I have that graph paper. And here's what I did. I wrote some notes, and I would encourage you guys to pause the video and write these out if you feel like you need to remind yourself of these things. Okay, so first of all, big, very important concept. It's the sun that provides the energy that drives convection currents that produce winds. The sun does not heat the surface of the earth evenly. It's not the sun's fault, it's the earth's fault, okay? Because since the Earth's axis is tilted, there are some areas that receive more direct sunlight than other areas, and because of the tilt of the axis, there are some areas that receive sunlight for longer periods of time, longer days and shorter nights, okay? Of course, those things change as the seasons change. But also, you need to recognize that the Earth is not evenly heated because land and water do not heat up the same way. So land and water heat differently. Okay, so we get different temperatures around the globe because not everything is absorbing heat evenly. And when we have different temperatures, we're going to have some areas with warm, less dense air, other areas with cooler, more dense air, okay? Air that's more dense typically has higher pressure. Air that's less dense has lower pressure. And you need to know that air will move from high pressure areas to low pressure areas. And this movement of air is what we know as wind, okay? So the movement of air from high to low pressure areas, that's wind, okay? And the bigger the differences in the pressure, then the stronger the winds. So if you have a lot of difference between your high and low pressure areas, you're going to have stronger winds, okay? Also, because the Earth rotates, winds do not move in straight lines, but they appear to curve because of the rotation of the Earth. And this apparent curving is called the Coriolis effect, okay? And then the rest of the lesson talked about types of winds. We talked about global winds. Those are large-scale winds that occur around the globe, okay? And they blow from a particular direction most of the time, okay? You have your trade winds, which occur between 30 degrees north latitude and the equator, and also between 30 degrees south latitude and the equator. You have your westerlies, which occur between 30 and 60 degrees, both in the northern and southern hemisphere. And then you have your polar easterlies, which occur between the poles and about 60 degrees north or 60 degrees south, okay? Now, when we talk about trade winds, westerlies, and polar easterlies, yes, we're talking about global winds, but we're talking about global winds that are surface winds, okay, that blow along the surface of the Earth. We also have some large-scale winds known as the jet stream. And the jet stream, those are upper-level winds. They occur high in the atmosphere, so they're not surface winds, okay? We have two jet streams that we need to remember. The polar jet stream and the subtropical jet stream. Both hemispheres have a polar jet stream. Both hemispheres have a subtropical jet stream, okay? All right, then your lesson ended by talking about local winds. Local winds are small-scale winds that really they can blow from any direction. And the direction that wind is coming from a lot of times depends on the land features that are in that area. Okay, we talked about sea breezes and land breezes. Those are one type of local wind. And then we had mountain and valley breezes. That's another type of local wind. Okay, so just down here I put two little reminders about winds. Okay, winds are named by the direction that they blow from. So if you're talking about a north wind, it's blowing from the north toward the south. Okay. Also, reminder that wind is created as air moves from higher pressure areas to lower pressure areas.